Let's talk a little bit about quadratic functions, and then we can do a problem that involves finding the vertex. So we know that quadratic functions in general look like this, right? We've got a, b, and c are real numbers, x, these are the variables. So the big deal is that we've got an x squared term. So if we wanted to, we could take and given something like this, we could complete the square on x and write it like this. So if you need a little review on completing the square, there's definitely information about that you can go and review. But if we took these two terms here with the x's and we did that completing the square process, we would come up with something that looks like this. So if we have our quadratic function in this form, we can maybe appeal to transformations that we've done in the past. So let's look at an actual example. So if we have maybe 2x plus 1 squared. So if we're looking at this one and we're thinking about just in terms of transformations, we would be looking at a function that looks like this, and we know really quickly that that graph looks like that guy. And we can, we could plot a few points, right? 0, 0 is on there, negative 1, 1's on there, 1, 1 is on there. So we've got these 3 points that are on there. And we can think about this in terms of transformations. So the lowest point on our function on the simpler one, the lowest point on there is the point 0, 0. Well, if we look at this, this other one, in terms of transformations, what's going to happen here is we're going to take all of our x values, and when we add 1 to the x, this means we're going to move left. So this here, we're going to go left 1. That's going to be our first step, and then our second step is we're going to do that. We're going to multiply y values by 2. So if we take all of these points that are here and we want to draw this function, oops, kind of off the page there. We want to draw that function. We can just take all of these points and move them left 1 and multiply all the y values by 2. So if I want to draw my picture, I can start with this point right here. I would start at negative 1, negative 1. I want to move it left 1 and multiply the y value by 2. So if I take this point and I move it left 1 unit, I'm going to be at negative 2, 1. And then I'll multiply the y value by by 2. So we'll be at negative 2, 2. So negative 2, 2. Okay, so this point corresponds to this point here when we move it left and multiply the y value by 2. So we can do the same thing here with these other ones, right? So I can move this piece, the vertex here, that point, we move it left 1 and multiply the y value by 2. Well, it's just going to stay put, isn't it? So we move it left 1 and multiply 0 by 2, we still get 0. Okay, then we can do this point, we move it left 1 and we multiply the y value by 2, we're going to be right here. Okay, so we can draw our nice graph. Okay, so in general, we can think about something like this as being a transformation of this guy, right? So we're going to move left or right, depending on what our h value is, and we're going to multiply our coordinates all by this value of a. And in our example here, we didn't have a k value here. I mean, we could just write plus 0 if we wanted to, and that would be corresponding to our k value, right? So we would be shifting up this many units. So if we were to have shifted this up, that would come last, right? Okay, anyway, the point is that we're taking the simpler one that we know has 0, 0 as a vertex, and we're just moving the vertex around. We know that just the general shape of this, if it opens up, that vertex is going to be a minimum. And if that vertex if the parabola opens down, then this vertex is going to represent a maximum, right? Because that's the largest value that this is going to take on. So really what we're looking for minimums and maximums, whether or not we're looking for a minimum or a maximum, we're looking at this front value right here. So our front value in our example was a 2, and we multiplied all of our y values by 2. So the orientation of this curve, right, it's pointing up in the original one, and it's pointing up in the result one as well, right, because we multiplied everything by a positive value. Now, if for example, we would have just a real easy one, f of x is maybe negative x minus 2 square plus 1. So we can draw this guy by moving our x values right to, we want to multiply our y values by a -1, and that's this part. And then third, we're going to shift up 1 because of that piece, right? So if we wanted to, we could take our original graph, y equal x squared, and just perform all these transformations. So we go right 2 with all the values, so all these go right 2. We're going to multiply all the values by -1, and that's the part that we're kind of concerned with here. When we multiply all the y values by -1, that's just going to take this and flip it upside down so it looks more like that guy. So why don't we start actually doing this? So if I took my points, if we take the point that was on the original one, maybe I'll write that or draw that with a little dashed line. So this is y equal x squared. If we wanted to now draw, maybe we'll draw it in green, all the values that belong to this one, we want to draw a picture of this. So we take all these x values, we move them right 2 units, multiply the y values by -1, shift it up 1. So we go from here, -1, 1, we're going to move right 2, so boop, boop. We're going to multiply that y value by -1, so instead of being at 1, we're at -1, and we're going to shift up 1 unit, so we're here. Okay, do the same thing with our corresponding vertex point. We can move it right 2 units, 1, 2. We can, okay, so right 2 units, multiply the y value by -1. So the y value here is 0, multiply that by -1, well, it's still 0. So then we shift it up 1 for that third step, so there we are. Okay, we do the same thing for this third one. So we take it, move it right 2 units, 1, 2, multiply the y value by -1, so we're down here, we shift it up 1, so there we are, and we can draw the nice curve. Connect the dots. Okay, so this is our function here. Okay, so what we're trying to do in this nice video is just look at where the vertex is. So the vertex is right here, and that is a maximum value for the function because our leading coefficient is negative, right? This is the part that in our transformations flipped us upside down. So the negative number out front is going to tell you whether or not the parabola opens up or down. If we have a positive value up front, like in our first example, that parabola is still going to face up. But if the leading coefficient is negative, like in that second example, it's going to open down and it's going to give us a maximum value.